Hi HPC, here is a review for day 2 for angles and their measures. So we were talking last class about some of the angle measures, and today we're going to focus on radians and how to convert between degrees and radians, and also how to do complementary and supplementary angles both in degrees and in radians. So first thing is, what is a radian? A radian is the actual length of the arc formed by an angle. Excuse me, so if I set up a set line or a set distance that goes from the center out to the outside edge, that's a radius, right? So the radius is the same thing as 1 radian. Take that same exact amount, allow it to curve around the outside edge, and that same exact amount is considered 1 arc length. Okay, so that's the radian, that's radian. The arc length is 1 radian. Okay, so if we look at a unit circle, in a unit circle, we always set up the radius to equal 1 to make everything easy, like it's a standard size, it's 1. So that means the radius is 1, that would be 1 radian. So 1 radian goes here, 1 radian goes here. Shortcut for that, or a shortened version of that, is just 1 rad, R-A-D for radians. So we know our circumference is usually 2 pi r, or you might have learned it as pi d. And again, diameter is just 2 radians multiplied together. So, sorry, 2 radius is added together. So then the circumference would just be 2 pi times our radius, which is 1 radian. So our circumference is 2 pi radians. So 1 full circle is 2 pi radians. Cool. All right. So we have the following conversion then. So we know a full circle is 360 degrees. And in radians, that's going to be the same thing as 2 pi radians. Okay, now officially we should be writing the degree symbol and the word radians afterwards. Sometimes we forget, and if we forget in a trig unit, it's assumed to be radians, not degrees. So if you want to make sure it's a degree, you got to put in the degree symbol. So let's take a look at the circle, and we'll measure it first in degrees and then in radians. So first in degrees, 0 is right here. We know this is a 90-degree angle as I move up this way. So again, imagine this is your initial ray to an angle, and your terminal ray is ending up first here, and then this way would be 180. Another 90 from that would be 270. And then another 90 from that would be 360, and it would just continue going around adding 90s each one of those times. If I was going to do this in radians, then this becomes 0 radians. Okay, this is back around is going to be 2 pi radians. So halfway around would be over here. This is 1 pi radians, or we just say pi radians. That means that this one is 1/2 radians, and we'll usually say pi over 2 radians to just put it into all one fraction. And then down here would be 1.5 radians, and we'll usually say 3 pi over 2 radians. Cool? All right, on to the next part. Sketch each radian angle in standard position. So think about the fractions around the unit circle. So here's how we do these. You look at the denominator first. Okay, and the first thing you do is you start over here and you call this 0/4, and you call this 4/4, because remember it is equal to pi, right? So 1 pi is 4/4. Okay, so if that's 4, if it took 4 pieces to get over there, where would 1 piece be? Well, 2 pieces would be here, so 1 piece would be right here. So this is where pi over 4 is. Okay, all right, in the next one we're doing in 6. So in 6, this would be 6/6 pi, and I want to find out where 5 is. So I have to imagine that I'm going to take this whole semicircle at the top and split it into 6 equal parts. Well, I know this part right here would be 3/6, right, because that's a half. So that means I need to get a 4 and a 5 in here. So here's 4, here's 5. So I would put it right about here. Okay. Next one is 4/3 pi. So again, we're going to think in terms of thirds. So this is 3/3, and 4/3 is more than that. So this is going to go down into the next quadrant. So this is 3/3, and then to make it all the way back around is 6/3. This one doesn't divide equally, like it almost even doesn't have a half. It'd be, let's see, it'd be 4.5 pi over 3. That's kind of weird. So instead, I'm just going to imagine that I am dividing that bottom semicircle into 3 equal parts. That would put a part right about here and a part right about here. That give me my 3 slices. So we want, where is the 4th third? It'd be right about here. Okay, and again, we're always using those denominators to help us. All right, so once we get the hang of it, then we can stop doing every single angle along the way and just kind of estimate them. So here we go for an 11th. I know this is 11 elevenths pi. I know this is 22 elevenths, and they want me to be at 20. So I'm going to imagine that I'm dividing the bottom into 11. I'm not going to waste my time trying to evenly divide 11 slices. I'm just going to say that's got to be really, really, really close to a full circle around. And I'm just going to put it right about here and call this 20 pi over 11. Okay, and then the last one, 4 pi. So we said this is 0 pi and then 2 pi, and it's also 4 pi, right? Every time we go around is another 2 pi. So that makes this one our last one, which is 4 pi. Okay, so I hope that helps thinking in fractions. So we're going to try it again. This time we're going to do negatives. That just means that when we start out with 0 pi, we're going to head this way into 4th quadrant first. And it's the same idea. By the time I get to here, it's over here, it's going to be 1 pi. And then by the time I get back, it's going to be negative 2 pi. So we're going to work in thirds this time. So we know that by the time we get here, it's negative 3/3 pi. So 1/3 would be right about here. So that is negative pi over 3. Okay, next one I'm going to work in fourths. That means negative 4/4 is over here. And that also means that negative 8 pi over 4 is over here. So 7 would be just 1/4 away. And I know fourths are like 45 degree-ish, right? If this is a half, then this is a fourth. Just cut it in half. So negative 7 pi over 4. All right, next one. We're dealing in sixths. So I know that this is negative 6 pi over 6. They want me to go to 7. So again, I know that another 3 would be up here. So I'm looking at about 1/3 of the way here. So negative 7 pi over 6. Right, here would be 8 pi over 6, 9 pi over 6. Get the idea? All right, on to the next one. We're dealing in halves. So this is negative 2 pi over 2. This is negative 4 pi over 2. So negative 3 pi over 2 would actually be right here. And our last one, negative 9 pi. Well, I can see that when we were doing it in pink, that the right-hand side was always the negative evens, negative 4 pi, negative 6 pi. So this side has to be all the odds. So this is going to be where negative 9 pi is, which is right over here. Cool, so I hope that helps. So you're just constantly re-breaking like a half circle into even pieces, okay? All right, coterminal we talked about in practice a little bit in last class. It's how to say that you were there by going around more times or less times. So if we're dealing in radians, that we just have to remember that that's going to work a little bit differently, right? It's still the same picture though. So if we wanted to find coterminal for pi over 4, visually we're right here. So we did from here to here. We show the arrow to say that's the way we went. So if I wanted to do coterminal to it, I could either go around a whole nother time and end up at the same spot, or I could go around the other way and stop. And there's an infinite number of these. I could go around one more circle from the red, I could go around one more circle from the blue, and so on. So if I'm dealing in fourths in radians, and I know that a full circle is 2 pi radians, then all I have to do is take the original angle and add or subtract 2 pi radians. 2 pi, why am I putting that over a fraction? 2 pi radians. So in our case, we have a pi over 4. So in a pi over 4, 8 pi over 4 would equal 2 pi. That's a full circle, right? So I'm really adding 8 pi over 4. So in this case, I'm going to be doing pi over 4 plus or minus 8 pi's over 4 to get coterminal. And I can keep adding those. I can add 16 over 4. I can subtract 16 over 4. I can add 24. I can add 80. Any of those multiples of 8 pi over 4. So I was given a 1/4. So if I wanted to add it, that would just be a 1 plus 9 would be 9/4. If I subtracted it, I could get 1 minus 8, that'd be negative 7/4. And you could double check those and try to graph those and see that they're exactly in the same spot. So all we're going to do is we're going to turn our 2 pi in, just like when we were graphing, figure out what a 2 pi is in that denominator, and then add or subtract to it. Let's try that again. Okay, so this one is 5 pi over 3. So I know that this is 0/3 pi, this is 3/3 pi, this is 6/3 pi. So 5/3 should be right about here, and that's assuming that I went around this way. So I know that if I'm doing in thirds, I'm doing 5 pi over 3 plus or minus 6 pi over 3, right? Just twice as much on top. So one of the coterminals could be 11 pi over 3. Another one could be subtract, negative pi over 3 would get me to the same place. And I could even add another 6 pi to it and get 17 over 3. I could subtract another, I could get negative 4 over 3, and all it would do is increase the number of loops or the direction of the loop. All right, so in summary, to get coterminal angles in radians, we just add or subtract 2 pi radians as many times as you need to get a plus and a minus one. Okay, so if we want one positive and one negative, there's one positive and one negative. Okay, however, the 17 and the negative 4 are also a positive and a negative. Awesome. Okay, on to 13. Find one positive and one negative to 3 pi over 4. So since we're dealing in fourths, I'd be adding or subtracting 8/4, right? 8/4 is equal to 2 pi. So if I add 1, I'm going to get 11 pi over 4. And if I subtract an 8, I'm going to get negative 5 pi over 4. So there's my one positive and one negative. Okay, in the next one, I'm in sixths, so I'm going to be adding or subtracting 12 pi over 6. So if I add 12 pi, I'm going to get negative 5 pi over 6. And if I subtract, I'm going to have another negative. They want a negative and a positive, so I'm going to have to add another 12 pi over 6 to the one I just found. So if I'm already at negative pi over 6 and I add another 12, I'm going to be at 7 pi over 6. So I'm going to end up adding 24 pi over 6 and 12 pi over 6 because it had already gone around in the negative direction more than once. But in this case, we have to add twice to get a positive and a negative. All right. Visually, we can see how things work for fractions and that they're not too horrible. But if we wanted to convert back and forth, the conversion is that 2 pi is the same as 360. However, there are a few other fractions that we could use for that, right? If we reduce that down, we could say that pi is the same thing as 180. We could say that a half pi is the same thing as 90. Okay, so any of those work. We tend to use the one that just uses a 1 in it somewhere. So we like pi over 180 because it only has a 1 pi on top. So if I already have a degree, like 30 degrees, then I want to cancel out the units called degrees. So I would put 180 over here, and I would put pi on top of it, and this is radians. So now the degrees would cancel. And I would just have to reduce 30 over 180, and this would end up being pi over 6 radians. Cool. So we're going to be doing the same thing there. Okay, we're going to sketch it so that for you visual people, you can see it that way as well. Okay, but we're also going to be just calculating. All right, so if I'm calculating, I want the degrees on the bottom so that the degrees cancel out. Okay, so I'm going to be working in 135 over 180. Okay, visually, I'm looking at this. Ooh, where did I go? What just happened? There we go. Visually, I'm looking at this and I'm saying, hey, 180 degrees is over here, 90 degrees is over here. It's got to be somewhere in there somewhere. So if I just put it over here and I figure out how far it is from 90 or how far it is from 180, I'm going to do from 180 because we talked a little bit about reference angles before, and this would be a 45-degree angle right here. Okay, 45s, looking at 45s, right? I know I could get 2 of them in here. So these are going to be pi over 4s. So this is going to be 3 pi over 4. And that's just visually going, I know that's a 45, that's a 45, that's a 45, that's a 45. It takes 4 of those slices to get to 180. So this should be 3 pi over 4. Now how do I check that? Well, I have to divide and reduce the 135 over 180. So if I divide by 5, I will get, let's see, 13 would be 27 pi. And if I divide by 5 down here, I will get 36. And then if I divide out the 9s, hey, look, I'm at 3 pi over 4. Cool. So we have the mathy way and we have the visual way. All right, in order to do the visual way, you have to know how much a slice is and then figure out how many slices fit into 1 pi or 2 pi. All right, let's try that again. So in number 16, we've got 540. So the mathy way is just to make sure your degrees are down here, your radians are up here, so your degree symbols cancel. So I'm going to be working on reducing 540 over 180. If I look at it visually, 540, we know this is 0 and 360. This is 180, and then if I add another 360, it would be 540. Hey, 540, we're over here. Right? So this should reduce down to some version of an odd amount of pi. So does 180 go into 540? Hey, look at that, it does. It goes in 3 pi. So it's exactly the same thing as the terminal ray I just drew at the 180 degree mark. It just went around a whole bunch of times. So it would have gone around this many times. Okay, let's see, 180, yeah, that should work. All right, if I'm doing negative 270, so I would again just multiply it by pi radians over 180, and then reduce your degrees, and we're trying to reduce 270 over 180 with a pi. So with those, I can see that they're made out of 90s. So this is made out of 3 90s, and this is made out of 2 90s. So we're going to end up at negative 3 pi over 2. If I was doing negative 270 on my own, I would know that this is 0, this is negative 180, this is negative 360. It's got to be somewhere in between there. So how much in between there? Well, I'm going to subtract it from 360. That's going to give me a 90. I know I'm going to be right here. And then I just have to show how I got here. So this would have been going around this way. Okay. All right, and then we've got one more, it looks like. This one is negative 2817, and it says convert this one. Okay, so we multiply it by 180 degrees on the bottom, pi radians on top, and we start reducing. So negative 217 over 180 with a pi. So what do they have in common? Doesn't look like they have anything in common, right? They're not both divisible by 2. On top is not divisible by 3. It's not divisible by 5, right? So that's why they're saying just write it in terms of pi. There you go. And then you could also write it as a decimal pi, which let's go see if I have a calculator here. So I readjusted my screen some here so I could figure this out. So I'm going to do 217 divided by 180, and the decimal it's going to give me is negative 1.21 pi radians. Again, just to make sure I didn't miss anything, I'm going to go to math, turn it into a fraction, and make sure there's no other fraction. Nope, that's it. That's the only fraction that would have worked. So write it as a decimal. So where is negative 1 pi? So remember that this is 0 pi and 2 pi, and since we're doing negatives, and this is negative 1 pi. So if I start out here and I go down this way, they're basically saying go 1 and then about another 20% of the way. That's going to put me right about here. So about negative 1.21. Awesome. All right, what if we're going to convert backwards? So if we're going to convert backwards, we're just going to flip the fraction that does the converting. So if we start out with a radian, so let's say that we start out with pi radians, and we want to convert it, we just make sure that the radians are down here so that the word radians cancel out, and we put 180 degrees on the top side. So now radians cancel out, pi's cancel out, and we're just left with 180. All right, so let's go try one of those. So negative pi over 2. So again, I'm going to just draw another fraction. I'm going to make sure pi is here and 180 with the degree sign is on top of it. The pi's are going to cancel, and I'm really just doing negative 180 degrees over 2. That's negative 90 degrees. If I were doing this in graphing, I would have said that this was 0 over 2 pi. This was negative 4 pi over 2, right? Because we're using the denominator. And then this would have been negative pi over 2, negative 3 pi over 2. And we were looking at negative pi over 2, negative pi, 2 pi over 2, and then also 5 pi over 2. Got it. So if 0 starts here and negative 2 is over here, then negative pi over 2 is right here. So visually that is 90 degrees to get there, negative. So negative 90 degrees is our conversion. Okay, what about 9 pi over 4? So then we're going to redraw this entire graph again in fourths. So this is 0 fourths and then 8 fourths. So we want 9 fourths. So this is going to be 4 fourths. And then I add another 8 to that, 12 fourths. So it's not all the way to 12. So visually, if I do this one to 9 first, I would end up at 8, and then another quarter would put me right here. So this would be where 9 pi over 4 is. And I would have had to go around one whole time to get there. All right, well, how many degrees is that? Well, when I'm cutting things into 4, that's 4 pieces that make 90. That's so that's half of 90 degrees. That's 45 degrees. If I want to use the formula, I put pi radians down here so that the pi radians cancel. 180 up here. And now I'm looking at 9 times 180 all over 4, and I start reducing. Okay, so if I start reducing these, we would end up with the 4 turns into a 2, this turns into a 90. This turns into 1, this turns into a 45. So whatever 9 times 45 is, would be 405. Remember, 360 goes around one full time, and then after 360, that extra little bit is 45 degrees. Okay, all right, let's try this one again. So we've got negative 2 pi over 3. So we're just going to multiply with the pi radians at the bottom and 180 degrees at the top. Okay, now I know the pi's are going to cancel. I can see a 3 goes into 180 60 times. So I've got negative 2 times 60 should be negative 120. All right, if I do these as radians, this is 0 over 3 pi. This is negative 2 over 2 pi. This is negative 4. Oops, how did I go into those? 3. Negative 3 over 3 pi. And then back over here would be negative 6 over 3. This is negative 2. It doesn't even make it all the way around. It's right about to here. Right, so imagining that I'm breaking it up into thirds. Okay, and they're saying that's about a negative 120. Well, yep, that looks about right. It's a little bit after negative 90 by another 30 degrees. Beautiful. All right, here goes another one that does not reduce. So we're going to take pi over 7. We're going to multiply it by 180 degrees over pi. And we're going to get 180 degrees over 7. So it says write both as a fraction and as a decimal. Okay, as a fraction, it's 180 over 7. And then if I wanted to do it as a decimal, I would take my calculator and do 180 divided by 7 is about 25.7 degrees. So 25.7 is still in the first quadrant. And we just say it's 25.7 degrees. Cool. Pi over 7 would have required me to try to divide this top part to get 7 over 7 to here, of trying to divide this into 7 equal pieces. So 1, 2, 3, 4, 5, something like that. Ugh, 7 is hard. All right, so how about finding complements and supplements in radians? It's really just making the adjustment to going from degrees to everything else. So in complements, angles that add up to 90 are called complements. In radians, they just have to add up to pi over 2. So if I'm looking for find the complement of each angle, I'm trying to figure out what do I have to add to this to get pi over 2. Now this could be a super yucky algebra equation to solve for x, or save yourself some hassle and turn this into the same denominator. So instead of it being 12ths and 2s, I'm going to say pi over 12 plus what equals 6 over 12. Well, now with the same denominator, the top becomes really easy. I have 1 pi, I need to get to 6 pi. That's got to be 5 pi over 12. Okay, so same deal for this one. I'm trying to figure out how to get to pi over 2. Save yourself some hassle. Call it 3 pi over 7 plus what equals, and in this one, I would want to make it equal to 7s. Look, so that would be 3.5. Right? So that's super yucky. So let's just double it. So we will call this 6 pi over 14 plus x equals 7 pi over 14. Ah, that's easy. That's pi over 14. That's just one of them. Okay, you can also do the algebra method and just solve for x. All right, in supplements, things add up to 180. Angles add up to 180. So in our case, 180 is just 1 pi, radians. Did I say radians on this one? No, I didn't. Radians. Okay, so if I want to figure out these, it's what do I have to add to this to get to pi? Again, let's turn them into common denominators if we can. So 5 pi over 6 plus what equals 6 pi over 6? Well, that's easy. It's just pi over 6. It's just one more. Right? If I'm trying to figure out what do I have to add to this to just get to 5 pi over, whoa, hello, we're doing pi's. We're doing supplements. So 10 pi over 10, then I would just have to add 3. Done deal. All right, so supplements always add up to 180, or if you're in radians, it's pi radians. All right, that's it for today, you guys. Thanks.